Hello everyone. In our last class, we discussed different atomic models. J.J. Thomson's atomic model, Rutherford's atomic model, and Bohr's atomic model. Right? Once again, we recall Bohr's atomic model. Right? Then Bohr's atomic model. Right? Then Bohr's atomic model consists the electrons or revolve around the nucleus in discrete paths in circular motion in its discrete paths. That means the electron will revolve in its own path. Always the electron which is present in this path, then always it revolve in its own path only. Right? This paths he called as orbits or shells. That means the electrons are revolve in own shells. Right? Then the electron while revolving in its own shell, it never loses its energy. Right? Until to revolve the electron its own path, its energy will not loses out. That's why he said that these paths, these shells is called as energy shells. That means then the shell consists the energy. Because of that reason, the electrons is revolving in its path, then this energy shell is equal to the energy of a electron. Got it? Like then is second shell and third shell, fourth shell. This electron is revolving in fourth shell unless until to change its shell, its energy is constant. It never loses its energy. Got it? Right. And that's why he has given the names for shells. Bohr has given as names like K shell, L shell, M shell, N shell. Got it? Like that he has given numbers also. 1, 2, 3, 4. Got it? K shell, L shell, M shell, N shell. And the energy levels are different. Right? The K shell is very closer to the nucleus, and comparing in this atom, the K shell has lowest energy. Right? Here. That means all energy shells are different in energies. So let the first cell energy is E1, second cell is E2, third cell is E3, and fourth cell is E4. Right? This is the lowest energy. Got it? This is the highest energy. Got it? Then E1 is less than E2, less than E3, and less than E4. Got it? Right? Then here one more important fact is that if electrons gain extra energy, sometimes the electrons can jump from one shell to another shell. Electrons can jump from one shell to another shell. Now here electron is jump from lower energy level to lower energy level to higher energy level. Right? When electron is jumps from lower energy level to higher energy level, that electron will gains the energy. By gaining energy, it can jumps from lower energy to higher energy. Got it? Right? Gains energy. Right? Then here lower energy is called as ground state. As mentioned that the lower energy is ground state, then higher energy is said that excited state, right? Lower energy is the ground state. He mentioned as a lower energy as a ground state, and higher energy is excited state. Okay, and here, sir, whether when electron it jumps from lower energy to higher energy, then here to, then it jumps from, for example, here to here, right? Sir, the energy, the electron which is jumps from lower energy to higher energy by gaining some energy, right? Sir, that electron will be stable in excited state. Got it out? Then the electron which is jumped into the excited state, which is reached to the excited state, it will be stable in that? No. Again, after the sometimes, then the electron comes into its own state, right? Then again it jumps from higher energy to higher energy level to lower energy level. Got it? Have understood? Here from lower to higher, it jumps from gaining, but here it loses, right? By losing its energy, it jumps from higher energy level to lower energy level, right? That means the electrons will not be stay when they jumps from lower energy to higher energy level. They will not be stay there. They come into same path. Again, they reaches its own path by losing their energies. Okay. And one more important point. He said that electrons, they revolve either in K shell or either in L shell, but not in between the K and L shell. Why? Because he knows that energy is quantized. That means energy is emitted. Right here, while gaining, while losing, it loses the energy now. Then how much energy it loses, sir? Or either how much energy it gains, sir? For that, we have a principle that is given by Planck's h nu. Right? It jumps from E1 to E2. That means E2 minus E1 equal to h nu. This is the principle to measure the energy gained or energy loses. Right? The electron is energy gained or loses. We will use this principle, E2 minus E1 equal to h nu. Here h is the Planck's constant. Planck's constant. We know the value. How much? 6.626 into 10 to the power of minus 34 joule second. Got it? Right? Then so always the energy is quantized. That means either the energy is released as 1 h nu, 2 h nu, 3 h nu, and so and so, so and so, so and so. Got it? But not 1.5 h nu, 1.75 h nu. Why? Because energy is quantized. Right? Got it? And he successfully explained hydrogen atoms line spectra. He explained hydrogen atoms line spectra. Okay, right? But in Bohr's atomic model is also, it has one drawback. The drawback is he explained successfully line spectra of a hydrogen atom. But when observed with a high resolution spectrum, then it has given fine spectra. It has given fine spectra. For example, this is a line spectra of a hydrogen atom. We have in a textbook we have these lines, right? Line spectra. Okay. Then here, when we observe with a high magnified spectrum, then this one line spectra is splits into another small fine spectrums, right? It splits into another fine lines that is called as fine spectra. But he was unable to explain the fine spectra. Right, what is fine spectra? Line spectra is splits into again fine lines. Why that fine lines is emitted? That was not clearly explained. That was not unable to explain it by the Bohr's atomic model. This is the drawback of Bohr's atomic model. Got it? Right? Then to overcome the drawback, and one more scientist is came out. That person name is Sommerfeld. Who is that? Sommerfeld. Now we are going to discuss Bohr-Sommerfeld model of an atom. Bohr-Sommerfeld model of an atom. Okay. Here Bohr's atomic model is unable to explain about the fine spectra. Right? This atom is came out to explain the fine spectra. Okay. Then actually the Bohr's atomic model consists of circular orbitals. Okay. Then instead of the circle, then he included along with the circular orbitals, the Sommerfeld is included elliptical shells. Included elliptical shells. Okay. If n equal to 1, n means principal quantum number. L equal to 0. L means what? The angular momentum quantum number. The angular momentum quantum number. Right? Sir, what is principal quantum number, sir? What is angular momentum quantum number, sir? We will discuss in our next class. Okay, very clearly. Right? Here. Then for first shell, it has only one subshell, that means L equal to 0. That will be in circular path. Okay. Then for a second shell, means here n equal to 2. N equal to 2. Then it has two L values, that means L equal to 0 and one more L equal to 1, that will be in elliptical shape. Elliptical shape. Right? Then if n equal to 3, that means third subshell, third shell, n equal to 1, first shell, K shell, that means your K shell, it is L shell, it is M shell. Right. In this case, it has 3 angular momentum quantum numbers, that is, I will give you, it consists of elliptical shells like this. Then L equal to 2, L equal to 1, L equal to 0. Got it? Right? In third shell. In fourth shell, he added 4 subshells. Those are, now see it. Okay, this one. That means here L equal to 0, L equal to 1, L equal to 2, L equal to 3. When n equal to 4. Like that, he introduced then elliptical orbitals. Elliptical orbitals. Okay, with this concept, he is successfully explained the fine spectra of hydrogen atoms. Bohr's and Sommerfeld atomic model, he explained successfully the fine spectra of a hydrogen atom. But he was unable to explain the larger, which has more than one electron. Hydrogen atom has only one electron, right? Then the atoms which has more than one electron, he was unable to explain the successfully. Right, got it? Then one more atomic model, quantum mechanical model of an atom. Okay, quantum mechanical model of an atom. Here then, if according to Bohr's model, the electron is revolve in discrete paths, that means in orbitals, right? When electron is revolving in orbitals, we can able to find exact position of an electron in an atom, right? If we can able to find exact position of a electron in an atom, to know the answer, we have to know some more answers for following questions. I have to know exact velocity of an electron, right? Right. Here, for example, if you want to search the objects in night times, if you want to search the objects in night time, we will take the help of torchlight. In dark room, then we will take a torch and we focus it on the objects to find the objects. Got it? Like that, like that, if an electron is revolving around the nucleus, right? Then one electron is revolving around the nucleus, right? Atom is a smallest particle. That too, the electron is subatomic particle. So it is very smaller. It is very smaller. Right, got it? Like that, like how we can search the objects in dark room, we will take the help of a torchlight. Like that, to find the electron in an atom, we have to use a smaller wavelength of light. We have to use a smaller wavelength. Sir, why we have to use smaller wavelength, sir? Smaller wavelength. Why? Because the size of the electron is very smaller, no? Right? Smaller wavelength. Smaller wavelength means higher in frequency. Right? We discussed it. Right? The wavelength is inversely proportional to the frequency. Right? Then higher in frequency means higher in energy. From E equal to h nu we got it, no? Then E is directly proportional to frequency. That means higher frequency, then higher energetic light we have to focus it on the electron. Right? If we focus this higher energetic source on the electron, it disturbs its speed and its path. Then when higher energy it falls, its path may disturb like this. Got it? Actually, then according to Bohr's atomic model, it is revolving in circular path, no? Then due to this energy, what happened? It disturbs its path and its velocity. Then we can't find accurate, right? It changes its speed, no? Then at that particular point we can't find accurate velocity. Got it? On account of this, then one more atomic model is introduced by Erwin Schrödinger. That atomic model is called as quantum mechanic model of an atom, and he introduced one more new concept that is called orbitals. Right? Orbitals. Sir, what is orbital, sir? Okay. Then the region of space where the probability of finding the electron is more or maximum is called orbitals. Got it? Right? He introduced the concept of orbitals. Instead of then that means the electron is revolves in the space around the nucleus some other. Okay, that was he introduced the orbitals, means the region or space where the probability of finding the electron is maximum is called as orbitals. He introduced it. Okay, these are the atomic models. Then you will learn clearly about the quantum mechanic model of an atom in further in classes. Okay, thank you.